What if I told you there's a reef off the coast of the United States that's bigger than the entire state of Vermont? And until just recently, scientists thought it was basically a dead zone. No tropical fish, no turquoise water. This thing sits in total darkness, 1,000 feet down, and it's absolutely enormous. This is the story of Million Mounds, and why almost nobody knows it exists. For decades, the Blake Plateau was written off. It's this vast, flat underwater terrace stretching about 100 miles off the southeastern coast of the United States, running all the way from roughly the latitude of Miami up to Charleston, South Carolina. Picture a submerged mesa the size of Florida just sitting between the continental shelf and the deep ocean abyss. And for the longest time, ocean scientists described it as a bleak, yet current swept plain. Just soft sediment, strong currents, not much going on. That perception started to shift around 2019 when NOAA kicked off a series of ambitious multi-beam sonar mapping campaigns. Multi-beam sonar works by sending out fan-shaped pulses of sound that bounce off the seafloor and return to a ship-mounted receiver. By timing those echoes, scientists can build incredibly detailed three-dimensional terrain maps of the ocean bottom. Think of it like LiDAR, but for the deep sea. Over the next several years, NOAA Ocean Exploration and a coalition of partners, including the Ocean Exploration Trust, the University of New Hampshire, the Bureau of Ocean Energy Management, Temple University, and the US, on geological survey, stitched together data from 31 separate sonar surveys and imagery from 23 submersible dives. What they found shattered every assumption about this region. The Blake Plateau was not a barren plain. It was covered, absolutely carpeted in coral mounds. The study, led by Dr. Derek Sowers and published in the journal Geomatics in early 2024, documented a cold water coral province spanning 6.4 million acres. To put that in perspective, that's larger than Vermont. It's bigger than Grand Canyon National Park many times over. The densest core of the reef alone, about 1.5 million acres, is bigger than the Grand Canyon Park boundary by itself. Within this colossal province, Sowers and his team developed an automated algorithm to identify individual coral mound peaks from the terrain data, and it flagged 83,908 distinct mound features. That number is staggering. The densest cluster earned the nickname Million Mounds because of the sheer concentration of formations packed tightly together. Other sub-regions like Richardson Reef and Stetson Banks have their own distinct character. Richardson Reef features tall linear chain formations, while Stetson Banks boasts some of the tallest individual mounds, with peaks rising up to 561 feet above the surrounding seafloor. The average mound height across the plateau sits around 65 feet, about the height of a 6-story building standing in pitch darkness on the ocean floor. But now here's where it gets really fascinating. When most people hear coral reef, they picture warm, sunlit tropical water, clownfish, sea turtles, snorkeling tourists. The Blake Plateau Reef is the complete opposite of that image. The dominant species here is Desmophyllum pertusum. You might also see it referred to by its older name, Lophelia pertusa. It's a stony, reef-building coral that lives between about 650 and 3,300 feet below the surface. At those depths, the water temperature hovers around 39 degrees Fahrenheit. There is zero sunlight. These corals are ghostly white, not because they're bleached, that's the crucial difference, but because they simply don't have the symbiotic algae that give tropical corals their color. Our deep sea corals cannot bleach in the way tropical corals do. They don't need algae or photosynthesis at all. Instead, they survive by filter feeding. They extend tiny tentacles and capture organic particles, bits of dead plankton, marine snow, microscopic debris that slowly drift down through the water column. And this is where the Gulf Stream enters the story. The Blake Plateau sits directly beneath one of the most powerful ocean currents on the planet. The Florida Current and the Antilles Current merge right over this plateau to form the Gulf Stream, and that constant flow does several critical things. It delivers a reliable conveyor belt of food particles, it flushes away sediment that would otherwise smother the coral polyps, and it brings well-oxygenated water into deep layers that would otherwise be oxygen-starved. Without the Gulf Stream, this reef almost certainly would not exist at the scale we see today. These corals are incredibly slow growers. We're talking just a few millimeters per year. Your fingernails grow several times faster in a single month than these corals grow in an entire year. Dead coral samples pulled from Blake Plateau mound features have been radiocarbon dated to between 5,000 and 44,000 years old. Some of the mound structures that we're looking at today could have started forming during the last ice age, building up layer upon impossibly slow layer across millennia. That glacial pace of growth is exactly what makes this ecosystem so vulnerable. If a mound that took tens of thousands of years to build gets scraped away by a trawl net or crushed by industrial equipment, the recovery timeline isn't years or decades. It could be centuries. It could be never on any human-relevant timescale. And yet, despite their fragility, these mounds play an outsized ecological role. Nearly 100 deep-sea fish species have been cataloged among the Blake Plateau reefs. The complex three-dimensional structures provide shelter, breeding grounds, and hunting territory for everything from squat lobsters and shrimp to golden crabs and commercially important wreckfish. The corals are what ecologists call ecosystem engineers, organisms that literally construct the habitat that an entire community depends on. Here's a twist most people don't know. The Blake Plateau wasn't just overlooked, it was actually mined. In 1970, a Virginia-based company called Deep Sea Ventures ran the world's first experimental deep-sea mining operation right on this plateau. They were after manganese nodules, potato-sized rocks rich in cobalt, nickel, and manganese that slowly accumulate on the ocean floor over millions of years. During the test, they deployed a crude airlift system that vacuumed roughly 60,000 nodules off the seafloor and pumped them up through a pipe to the surface. At the time, nobody fully understood what lived down there. The test lasted only about a month. It was considered a Cold War era technology demonstration, not a commercial venture. Fast forward to 2022, more than 50 years later, and scientists sent a remotely operated vehicle back to the exact same site. What they documented was sobering. Each of the mining equipment had carved grooves into the mud that stretched over 43 kilometers, and in those track paths, life had essentially not returned. No nodules, no sponges, no visible fauna. The surrounding undisturbed areas were teeming with biodiversity, but in the dredged corridors, just sterile sediment half a century later. That single month of experimental mining created scars that the deep ocean still hasn't healed. This discovery is now a key piece of evidence in the global debate over deep sea mining. The Blake Plateau serves as a living, nor rather non-living, as case study showing that the deep seafloor recovers on timescales far longer than industry models typically assume. Today, the Blake Plateau faces a complicated web of pressures. Ocean acidification is one of the most serious long-term concerns. As the ocean absorbs carbon dioxide from the atmosphere, seawater pH drops, and that makes it progressively harder for calcifying organisms like Desmophyllum pertusum to build and maintain their calcium carbonate skeletons. A 2025 study found that acidification has already crossed safe thresholds in large portions of the global ocean, particularly down to depths of around 650 feet, the exact upper range where Blake Plateau corals begin. Then there's warming. Dr. Eric Cordes at Temple University, one of the lead researchers on the Blake Plateau, has documented temperature spikes of 15 to 20 degrees Fahrenheit occurring in a single day over these reefs. Marine heat waves are intensifying, and while deep sea corals don't bleach the way tropical corals do, rapid temperature swings can still stress and damage them in ways scientists are only beginning to understand. Commercial fishing pressure is another factor. Deep sea fish species on the plateau tend to be large but extremely slow growing, which makes them highly susceptible to over-harvesting. Bottom trawling in particular can physically destroy coral mound structures that took millennia to form. And then there's the question of energy infrastructure and future mineral extraction. The same region that hosts this extraordinary reef also sits in waters that have been identified as potentially viable for deep-sea mining operations, and the U.S. conservation efforts are underway. The South Atlantic Fishery Management Council has established coral habitat areas of particular concern that restrict certain activities. But scientists and conservation groups are calling for more comprehensive, permanent protections. The Aspire campaign, the Atlantic Seafloor Partnership for Integrated Research and Exploration, continues to map and study the region, and organizations like the Natural Resources Defense Council have been pushing to elevate the Blake Plateau's profile in national conservation policy. The Blake Plateau story is really about how little we know about our own backyard. Less than half of U.S. marine waters have been properly mapped. For over a century, one of the largest living reef systems on Earth sat 100 miles off the southeastern coast, and we had no idea it was one continuous interconnected habitat. We called it a dead zone. We mined it. And it took a coalition of agencies working together over more than a decade of systematic exploration to reveal what was actually there. These cold water coral mounds play roles we're still cataloging, recycling nutrients in the deep sea, sequestering carbon, supporting commercial fisheries, harboring biodiversity we haven't even named yet, and they grow so slowly that the damage we do today won't be undone in our lifetimes or our grandchildren's lifetimes. The deep sea is the largest biome on our planet, and Million Mounds is proof that it's anything but empty. If this blew your mind the way it blew mine, hit that subscribe button and drop a comment. Did you have any idea this reef existed? I'd love to know. And if you want to see the actual sonar maps and ROV footage, I'll leave links to NOAA's expedition pages in the description. See you in the next one.